This is SpaceTime, Series 25, Episode 81. Coming up on SpaceTime, the ultimate fate of a star shredded by a black hole. Moscow adorning their Progress cargo ship with anti-Ukrainian propaganda. And the growing dangers of falling space junk. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers studying the destruction of a star by a black hole have unraveled another mystery in how stars are torn apart by these dark monsters. In 2019, astronomers observed a star very similar to our Sun as it was totally disrupted, that is, shredded and destroyed after passing too close to a black hole around 1 million times more massive. Located just 215 million light-years away in a spiral galaxy in the constellation Eridanus, the event, catalogued as AT2019-QIZ, was the nearest tidal disruption event ever observed up to that time. Luckily, it was also the first such event bright enough for astronomers to study optical light from the doomed star, specifically the light's polarization, in order to learn more about what happened after the star was torn apart. Their observations on October the 8th, 2019, suggest that a lot of the star's material was quite literally blown away at speeds of up to 10,000 kilometers per second. In the process, forming a spherical cloud of gas and debris, which blocked out most of the high-energy emissions being produced as the black hole ripped apart and consumed the remains of the star. Earlier, other observations of the optical light from the blast revealed that much of the star's matter was blown outwards by a powerful wind. A report in the Journal of the Monthly Notices of the Royal Astronomical Society claims the new data on the light polarization, which was essentially zero at visible or optical wavelengths when the event was at its brightest, tells astronomers that the cloud was likely spherically symmetric. One of the study's authors, Alex Filipenko from the University of California, Berkeley, says this is the first time anyone had deduced the shape of the gas cloud around a tidally disrupted star. The results provide one possible explanation as to why astronomers don't see high-energy radiation such as X-rays from many of the dozens of tidal disruption events observed so far. The X-rays are produced when stellar material is ripped from the star and dragged into an accretion disk around the black hole, where it's crushed and torn apart at the subatomic level before eventually passing the event horizon, a point of no return, and falling inwards towards the black hole singularity. It would appear the X-rays are being obscured from view by the gas being blown outwards by the powerful winds of the black hole. The findings rule out a class of solutions that had been proposed theoretically and gives astronomers stronger constraint on what happens to gas around a black hole. The polarization study supports earlier observations of winds emanating from similar tidal disruption events. The authors say you wouldn't get a spherical geometry without having a sufficient amount of wind. An interesting point of these observations is that a significant amount of the stellar material spiraling inwards doesn't eventually fall into the black hole itself, but is instead blown away. Many theorists have hypothesized that the stellar debris forms an eccentric asymmetrical disk after disruption, but an eccentric disk was expected to show a relatively high degree of polarization, which would mean that perhaps several percent of the total amount of light is polarized. And this was not observed for this tidal disruption event. However, a second set of observations on November the 6th, some 29 days after the October observations, showed that the light was very slightly polarized, about 1%, suggesting that the cloud had thinned enough to reveal an asymmetric gas structure around the black hole. Both observations came from the same 3-meter Shane telescope at the Lick Observatory near San Jose, California. The Lick's fitted with a CAS spectrograph, an instrument that can determine the polarization of light over the full optical spectrum. When light becomes polarized, its electrical field vibrates primarily in one direction. Then it scatters off electrons in the gas cloud. The accretion disk itself is hot enough to emit most of its light in X-rays. but that light has to get through the cloud. And there are many scatterings and absorptions and re-emissions of light before it can escape the cloud into free space. And with each of these processes, the light loses some of its photon energy, eventually going all the way down into the ultraviolet and optical wavelength ranges. The final scatter then determines the polarization state of the photon. So, by measuring polarization, astronomers can determine the geometry of the surface of where the final scatter happens. The polarized light was emitted from the surface of a spherical cloud with a radius of about 100 astronomical units. That is 100 times the average distance between the Earth and the Sun, which is about 150 million kilometers. Meanwhile, an optical glow of hot gas was emitted from a region of about 30 astronomical units. That's about the distance between the Sun and Neptune. The study's authors suggest that this deathbed scenario may only apply to normal tidal disruption events, not oddballs, in which relativistic jets of material are expelled at the poles of the black hole, forming quasars. But only more measurements of polarization of light from these tidal disruption events can answer that question. The 2019 spectropolarimetric observations, that is a technique that measures polarization across many wavelengths of light, showed that the zero polarization of the entire spectrum in October indicates a spherically symmetrical cloud of gas. All the polarized photons balance one another. Meanwhile, the slight polarization of the November measurements indicate a small asymmetry. Because these tidal disruption events are occurring so far away in the centers of distant galaxies, they appear as only a slight point of light. And polarization is one of the few indications of the shape of the objects. Filipenko says these disruption events are so far away that you can't really resolve them. You can't study the geometry of the event or the structure of the explosions. But studying the polarized light actually helps deduce some information about the distribution of the matter in that explosion, or in this case, how the gas and possibly the accretion disk around the black hole is shaped. This is SpaceTime. Still to come, NASA's new mineral dust detector, and Moscow adorns their Progress cargo ship with anti-Ukrainian propaganda. All that and more still to come on SpaceTime. A new NASA science package has just been delivered to the International Space Station. It'll monitor how dusty the Earth is and how that affects the environment. As climate change continues to alter the planet, some areas are drying out and becoming more dusty. That dust then rises up into the atmosphere and gets carried away by winds. Each year, strong winds carry more than 1 billion tons of dust from the Earth's deserts and other dry regions through the planet's atmosphere. While scientists know that this dust affects the environment and climate, they don't have enough data to determine in detail what those effects are or what the effects may be in the future, at least not yet. And that's where EMIT, the Earth Science Mineral Dust Source Investigation Instrument, comes in. Once it's attached to the International Space Station, the science package, developed by NASA's Jet Propulsion Laboratory in Pasadena, California, will fill in those gaps using a state-of-the-art imaging spectrometer, collecting more than 1 billion dust source composition measurements around the planet every year. This will significantly advance science's understanding of dust's influence across the Earth system. We know dust from Africa's Sahara Desert is blown across the Atlantic and ends up fertilizing the Amazon in South America. At the same time, dust from the Australian outback is blown across the Pacific Ocean, turning some of the snow on New Zealand's Alps pink. Desert regions produce most of the mineral dust that makes its way into the atmosphere. Trouble is, deserts are also largely remote places, making it difficult for scientists to collect soil and dust samples over these vast areas by hand. From its perch on the International Space Station, EMIT will map the world's mineral dust resource regions. The imaging spectrograph will also provide information on the colour and composition of dust sources globally for the first time. The dust will help scientists understand which kinds of dust dominate each region. It'll help clarify whether mineral dust heats up or cools down. You see, right now scientists don't know whether mineral dust has a cumulative heating or cooling effect on the planet. That's because dust particles in the atmosphere have different properties. For instance, some particles may be dark red, while others are white. Colour matters because it determines whether the dust will absorb the sun's energy, as dark-coloured materials do, or whether it will reflect the light, as light-coloured materials tend to do. If more of the dust absorbs the sun's energy than reflects it, it'll warm the planet rather than reflect the light away. Emmett will provide a detailed picture of how much dust comes from the dark versus the light minerals, allowing scientists to determine whether the dust is heating or cooling the planet overall, as well as how it's working individually and locally. The mission will also help scientists understand how dust affects different Earth processes. See, mineral dust particles vary in colour because they're made of different substances. For example, dark red mineral dust, such as that found in Australia, gets its colour from iron. The composition of dust particles affects how they interact with many of Earth's natural processes. For instance, mineral dust plays a role in cloud formation and atmospheric chemistry. When mineral dust is deposited in the ocean or the forests, it can provide nutrients and growth, acting like a sort of fertilizer. But when it falls on snow or ice, the dust accelerates melting, leading to more water runoff. And for humans, mineral dust can also be a health hazard when inhaled. Emmett will collect information on 10 important dust varieties, including those that contain iron oxides, clays, and carbonates. That'll allow scientists to assess what different types of effects different types of dust have on different ecosystems and processes. And hopefully the findings will also allow more accurate climate models to be developed, helping future predictions on how climate change will affect different parts of the planet. This report from NASA TV.
Mineral dust can travel thousands of miles where it interacts throughout the Earth system. In our case, we're going to study how that mineral dust heats or cools planet Earth. Currently, we aren't sure whether mineral dust heats the planet or cools the planet.
We're looking at dust sources on the Earth's surface, so deserts, arid regions. Wind can basically emit that dust into the atmosphere. And so we are very interested in knowing what it is, and depending on what it is, it'll tell us whether or not it is warming or cooling our environment.
And some minerals are dark, maybe more red. They would absorb solar energy, and they could be heating elements. Other cases, minerals are bright white, and they could reflect sunlight back into space and cool the atmosphere.
And these desert dust plumes, once they get into the atmosphere, they are not small. If you look at some of the satellite imagery, you can see these huge desert dust plumes, larger than Spain, for example, coming across the North Atlantic.
So this is an important impact potentially on climate change looking into the future. As more lands become dust-forming regions, as they become desertified, we'll want to understand how those changes will affect our climate in the future.
This experiment is so important for us to understand what's going on at the surface of the Earth in terms of the mineralogy and the composition.
First, we're launched on a resupply service vehicle to the International Space Station. And once we're on the ISS, we would attach to the exterior of the space station. And I can't imagine a better platform than the International Space Station to measure Earth science.
EMIT is an imaging spectrometer, so it has a telescope, which basically collects a lot of light, and we image all of that light onto the slit of what we call a spectrometer.
That measures light in many different wavelengths of the electromagnetic spectrum. Our eyes see 3 wavelengths, red, green, and blue, but EMIT sees in hundreds of wavelengths out into the infrared.
They give us signatures like fingerprints.
As we're traveling on the ISS, looking down at Earth, focusing on the spectral characteristics of minerals that are on the Earth. And so the imaging spectrometer allows us to detect those spectral signatures that tell us what type of mineral they're actually looking at.
This is setting a new benchmark for the quality of this class of instrumentation. This is just extraordinary.
It's really a convergence of state-of-the-art technology and state-of-the-art science so that we better understand the climate system and how it's responding to humans.
And in that report from NASA TV, we heard from NASA JPL Principal Investigator Robert Green, Instrument Engineer Christine Bradley, also with NASA JPL, Deputy Principal Investigator Natalie Mahoward from Cornell University, as well as Instrument Scientist David Thompson, Project Manager Charlene Ang, and Systems Engineer Ernesto Diaz, all from NASA JPL. This is SpaceTime. Still to come, Moscow adorns their Progress cargo ship with anti-Ukrainian propaganda, and later in the science report, a mysterious global tsunami which circled the Earth in August 2021. All that and more still to come on SpaceTime. A Russian Progress cargo ship carrying 2.5 tons of supplies has successfully docked with the International Space Station. The Progress MS-20 docked onto the aft port of the station's Visitor Service Module 3.5 hours after launching aboard a Soyuz 2-1A rocket from the Baikonur Cosmodrome in the Central Asian Republic of Kazakhstan.
Progress lifting off today, there will be one delta velocity burn to align Progress's orbit to match that of the International Space Station. Because this is a quick 2-orbit rendezvous and a narrow phase angle for launch, not as many burns are required to align the orbit of Progress to the International Space Station. Propellant drain back is underway. Weather looking good, 85 degrees, clear skies. Coming up on the 2-minute mark, the first stage is being pressurized for flight, optimizing the flow of fuel to help add structural support to the rocket. At about the T-minus 30-second mark, the first of 2 servicing umbilicals will retract from the booster, followed about 15 seconds later by the retraction of the second umbilical that will initiate the auto sequence start for engine ignition. Progress now on internal power, and we have separation of the first of the 2 umbilicals, T-minus 20 seconds and counting. Auto sequence has been initiated. We have a command for engine sequence start. We have it engine ignition, turbo pumps building up to flight speed, and the second umbilical has retracted. And liftoff. Liftoff of the Progress 81. Its destination, the world's only orbital laboratory, the iconic International Space Station. Good roll, pitch, and yaw program reported from Baikonur. First stage performance reported to be nominal from the blockhouse in Baikonur. Good vehicle stabilization reported. Good chamber pressure reported on the first stage. Now 1 minute into today's flight, passing through maximum dynamic pressure on the vehicle. All continues to be reported going well. Standing by for first stage separation. And first stage separation confirmed. The boosters falling away from the Progress vehicle. The vehicle now flying on second stage engines. Continuing to hear good calls from Baikonur, now approaching 2 minutes, 25 seconds into today's flight. The Progress booster traveling almost 5,000 miles an hour, hearing good calls on the second stage engines as well. Everything continuing to look good as we approach the 3-minute mark into the flight. 3 minutes, 15 seconds into the flight, the launch shroud has been jettisoned. Second stage engine performance going well, hearing good calls on the second stage. The vehicle continues to be reported to be stable. Everything is looking good. Second stage shutdown and separation, and the skirt has been jettisoned. Continuing to get good reports on the vehicle. Everything looking stable. Third stage engines performing as expected. 6 minutes and 45 seconds into today's flight. 2 minutes of powered flight remaining. Continuing to hear good calls. Just about 1 minute of powered flight remaining. Everything looking good. The vehicle is stable. 8.5 minutes into today's flight. Coming up on third stage shutdown and spacecraft separation. Third stage shutdown and third stage separation. The next step will be the deployment of the solar arrays and the navigational antennas on the Progress 81. The solar arrays now being deployed. It was a perfect launch from the Baikonur Cosmodrome in Kazakhstan, that launch occurring at 4:32 a.m. Central Time. Progress completed an 8.5 minute climb to orbit with everything going smoothly. Progress is now well on its way to the International Space Station. It will complete a quick 2-orbit rendezvous with a series of pre-programmed engine firings taking place to help bring Progress into the vicinity of the International Space Station for its automated docking scheduled at 8:02 a.m.
The supply ship has delivered food, fuel and other cargo for the station's 7-member international crew. Sadly, the Russian Federal Space Agency Roscosmos used the mission as a propaganda tool, painting the Soyuz with the inscription Donbass, that's the region of eastern Ukraine currently under brutal attack by the Russian military. Meanwhile, the nose cone of the rocket was adorned with the flags of the Donetsk and Lugansk People's Republic, areas of Ukraine stolen by Russia and currently under Moscow's control. Russia's also been adding a Z insignia to several recent Soyuz rockets. The Z is commonly associated with support for Russia's brutal military invasion of Ukraine. It was originally used as an identification mark for Russian ground forces as they entered the country, killing thousands of unarmed civilians. While Russia's invasion of Ukraine has heightened tensions, Russian cosmonauts and their American and European counterparts aboard the International Space Station have kept working as usual, or at least as usual as you can be under these circumstances. And flight controllers in both Houston and Moscow are also continuing to cooperate. 2 classified United States spacecraft have successfully been launched aboard a United Launch Alliance Atlas V Centaur rocket from the Cape Canaveral Space Force base in Florida. The 2 military surveillance satellites are designed to track fast-moving hypersonic missiles from geostationary orbit. One spacecraft, called the Wide Field of View satellite, is a US Space Force Space System Command testing platform for a new generation of missile surveillance technology. Current space-deployed weapons tracking systems focus on ballistic missiles, which have limited maneuverability. Basically, they go up in the air and then plummet back down to the ground, hitting their target. But the new Overhead Persistent Infrared Program system is designed to track next-generation hypersonic threats, such as Russia's new Kinzhal missile. Russian state-run media announced a successful test of the Kinzhal in 2018, claiming it's able to travel 5 times the speed of sound in the atmosphere while being highly maneuverable and still capable of striking targets anywhere in the world. So to track it, satellites need to be fitted with a new type of sensor designed specifically for hypersonic weapons detection. The Wide Field of View satellite is equipped with a 2-meter imaging sensor developed by the same company that supplied NASA with optical components for both its Hubble and James Webb Space Telescopes, as well as the new Nancy Grace Roman Space Telescope currently under construction. The second satellite in the payload is known as the US Space Force 12 Ring. It's based on a Northrop Grumman bus with 6 unique payload ports and an independent propulsion system. And it's carrying a number of different instrument technology demonstrator packages for the US Department of Defense. They'll be tested in orbit to see how well they work. A new study has found that wishing on a falling star could be deadly, especially if it's actually a rocket. A new report in the journal Nature Astronomy has found that there's a 10% chance that someone will be hit by a falling rocket or piece of space junk sometime in the next decade. Scientists say the risks are disproportionately borne by people in the global south, with rocket bodies approximately 3 times more likely to land at latitudes of, say, Dakar or Jakarta or Lagos compared to New York, Beijing or Moscow. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. A new study has concluded that drinking alcohol, even small amounts, offers no benefits to people under the age of 40. The findings, reported in the Lancet Medical Journal, found that Australians aged 15 to 39 had some of the highest rates of harmful alcohol consumption in the world. But there was some good news for drinkers over the age of 40. The analysis suggests that drinking a small amount of alcohol, around 1/2 to 2 standard drinks a day, may provide some benefits for this age group, including reducing the risk of ischemic heart disease, stroke and diabetes. The authors have called for alcohol consumption guidelines to be revised to include age as a factor, and they say current recommendations are simply too high for young people. A new study has warned that climate change is weakening many of the world's forests. The findings, reported in the journal Nature, show that climate change has caused some forests to experience big declines in resilience, that is, their ability to withstand and recover from environmental disturbances. Scientists say forests' important role in the global carbon cycle, potential mitigation for future climate change, protecting soil from erosion, and supporting biodiversity all requires resilience. The authors assessed changes in resilience between the year 2000 and 2020 using a combination of satellite images and artificial intelligence, finding that the resilience of tropical and temperate forests has declined over this period. The changes were linked to reduced water availability and increased climate variability. However, boreal forests, that is, typically those found in cooler regions of the Northern Hemisphere, bucked the trend, displaying an increased level of resilience, possibly because warming temperatures and increased CO2 levels are benefiting them. Overall, around 23%, that's almost a quarter, of the planet's intact undisturbed forests may have already reached a critical threshold, with resilience contributing to the decline. Scientists may have finally resolved the riddle of a mysterious global tsunami which circled the Earth in August 2021. The culprit was thought to be a magnitude 7.5 earthquake in the South Atlantic Ocean, off the coast of the South Sandwich Islands. However, the figures just didn't add up. The 47-kilometre depth of the quake was simply too far down to trigger a tsunami. Furthermore, the rupture was nearly 400 kilometres long, which should have generated a much larger earthquake. Now, a new study reported in the journal Geophysical Research Letters has identified another bigger magnitude 8.2 earthquake as the true source of the mysterious tsunami. Scientists identified the shadow, almost invisible magnitude 8.2 quake, finding it accounted for 70% of the energy released during the event. The study found the quake wasn't a single event, but 5, a series of subquakes spread over several minutes. And the third subquake was a shallower, slower magnitude 8.2 quake that hit just 15 kilometres below the surface. The hidden quake signal wasn't clear until scientists filtered out waves using a much longer period of up to 500 seconds. Only then did the 200-second long quake become clear. That's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.